There are moments in history when human curiosity leaps so far beyond its own limitations that it reframes the universe itself. The launch of the Kepler Space Telescope was one of those moments. Before Kepler, exoplanets were rare treasures, exotic anomalies discovered one at a time, each one a scientific triumph demanding years of patience and fortune. But when Kepler opened its dust-covered shutters and locked its gaze onto a single star field in the constellation Cygnus, humanity crossed a threshold. No longer were we passive dreamers scanning the sky for hints of other worlds. Kepler transformed us into cosmic census takers, capable of counting planets by the hundreds, then by the thousands. For the first time in human history, we began to grasp our true place in the cosmos, not in a lonely solar system, but in a galaxy teeming with planetary systems, each potentially harboring oceans, atmospheres, storms, perhaps even life. And yet, for all the euphoria Kepler brought, every discovery, every headline, every chart filled with newly found worlds, there was one signal that unsettled astronomers more deeply than any confirmed planet ever could. It was faint, brief, perfectly shaped, perfectly timed, and utterly singular. A single dip in the brightness of an otherwise unremarkable star. A momentary flicker so precise that it refused to be dismissed as noise, yet so fleeting that it offered no repetition, no certainty, no closure. Kepler had caught something astonishing, and then, just as quickly, it lost it. The planet revealed itself for only a heartbeat of cosmic time, then slipped back into darkness, never to be seen again by that telescope's failing eyes. What made it haunting was not the mystery alone, but the cruel clarity of the data. It was undeniably a planet, and yet it was irrevocably out of reach. A world that Kepler could not confirm, could not categorize, could not revisit. A world that existed, but only in that one fragile whisper of starlight. In all of Kepler's triumphs, this was the discovery that felt most like a wound, a reminder that the universe does not reveal all of its secrets, even to the instruments built to expose them. Every confirmed exoplanet requires consistency. A dip in brightness, then another, each one spaced exactly the same amount of time apart. But the monotransit refused to obey the rules. It arrived once, sharp and clean, cutting a perfect notch in the star's light curve. The geometry was flawless. The descent into shadow was smooth. The bottom plateaued with surgical precision, the exit gentle and unmistakable. It was, astronomers agreed, the signature of a world crossing its star. There was no doubt about that. But the star never dimmed again. Kepler waited as patiently as its fuel and hardware allowed. The world never returned. At first, scientists considered the simplest explanations. Perhaps Kepler missed earlier transits. Perhaps the orbit was so long that the next one would not occur for centuries. Perhaps the alignment of the planet's orbit was so delicate that only for a brief cosmic moment did it tilt into the telescope's line of sight. The idea was mesmerizing, that for just a single moment in thousands or tens of thousands of years, this world happened to pass between its star and Kepler, and we were lucky enough to witness it. But such luck felt almost supernatural. The cosmos is rarely so generous. The deeper scientists dug, the stranger the possibilities became. The planet might be circling in a wildly elongated, comet-like orbit, diving close to its star once per lifetime before slingshotting back into the cold dark for centuries. Or perhaps it was a rogue, an orphaned world wandering between stars, temporarily captured by the gravity of the host star before resuming its lonely drift through interstellar space. Some even speculated it could have been a planet with an enormous ring system, so wide that its transit shape was modified just enough to confuse the models. But none of these hypotheses accounted for everything. The event remained too clean, too precise to dismiss, and too isolated to understand. The monotransit became a paradox, the most convincing evidence for a world we could never confirm. The one discovery Kepler was not built to handle. A planet that simply refused to play by the rules. It is a strange thing to imagine a world that exists only in data, never in sight, never in color, never in the glow of a telescope's lens. But that is what the monotransit became. A world defined not by imagery or spectroscopy or repeated measurement, but by a single fleeting mathematical curve. And yet the physical reality behind that curve is vast, ancient, and magnificent. The depth of the transit suggested a giant, perhaps a super Jupiter, swollen and heavy, or a sub-brown dwarf, glowing faintly with the heat of gravitational contraction. Its orbit, if bound, must be breathtaking in scale. It could sweep so far from its star that its skies would dim into a permanent twilight, its atmosphere freezing into slow-churning waves of ammonia clouds and methane storms. Seasons on such a world might unfold over millennia. A single winter could outlast the entire written history of Earth. Picture a gas giant whose nightside temperatures drop to near absolute zero. Picture a world whose sunrise comes once every few generations, warming the clouds for a brief moment before fading again. Picture moons locked in deep ice, yet glittering under the distant star like jewels in the dark. This is not science fiction. This is what the data implies. A world cold enough to silence storms, slow enough to stretch time, remote enough to feel eternal. And yet, for all its grandeur, for all its possible beauty and mystery, the monotransit remains little more than a shadow, its physical truth inaccessible to us. Kepler is gone. No other telescope was looking at the star with such precision during the moment of transit. And because we have no period, we cannot schedule observations for the next crossing. The cosmos gave us one glimpse and then sealed the window shut, perhaps for hundreds of years. And still the data remains, silent and relentless, refusing to change, refusing to reveal more. The planet endures as an idea, a cosmic tease that reminds us how small our observational footprint truly is. When Kepler's gyroscopes failed and its fuel ran dry, its mission formally ended, but its impact had already reshaped human understanding. It showed us a universe overflowing with planets, billions, perhaps trillions, each one a potential cradle for climates, atmospheres, storms, even life. But the monotransit stood apart from every success. It was the failure that humbled the mission, the reminder that even as we discover thousands of worlds, there will always be those that escape our grasp. Perhaps that is why this single lost planet has captivated astronomers so profoundly. It represents the boundary of knowledge, the moment where detection becomes yearning, where data becomes philosophy. It asks us to accept that the universe contains truths we may never measure, never photograph, never confirm. Not because we are incapable, but because some phenomena unfold on timescales far beyond our mortal reach. To see only one transit of a 1,000-year orbit is not a failure of technology. It is a reflection of cosmic scale. Kepler's greatest failure was not that it missed the planet. It was that it found a world too vast and slow for any human generation to witness again. A world that reminds us that astronomy, is the art of catching fleeting glimpses of eternity. In the end, the monotransit is a haunting, beautiful symbol of our place in the cosmos. A world that moved across its star just once during the entire lifetime of our telescope. A whisper of existence traveling light years to reach us, only to vanish again into the silence of its impossibly long orbit.